In this video, I'm going to cover differentiability, try and clear up some of the discontinuities in my explanation. Get it? I'm also going to go over the calculator. Okay, so remember the derivative is the slope of the tangent line. So take a minute, graph f of x equals absolute value of x. Okay, so I'm going to plot the f prime of x here. We know that the slope at the origin, the slope of the tangent line is horizontal, therefore the slope is 0. For all positive values of x, the slope is 1. The tangent line of a line is the line itself. So this slope is 1. But be careful. At 0, the tangent slope is 0. So we need to have an open circle. Right away, this is discontinuous, which will be a sign that it is not differentiable at 0. So for all negative values of x, the slope is -1. So if the slope is -1, for all negative values of x, there you go. This is the graph of the derivative of the absolute value of x. So while the absolute value curve is continuous everywhere, its derivative is not continuous everywhere. So we have a problem here at 0. So we say that the derivative, or not the derivative, we should say, the absolute value of x is not differentiable at x equals 0. Discontinuous, therefore not differentiable. So another way we could look at this, we could say the limit as x approaches 0 from the left of the derivative. So the limit as x approaches 0 from the left is equal to -1. The limit as x approaches 0 from the right of the derivative is equal to +1. The overall limit doesn't exist, so these are not the same. So the limit as x approaches 0 of the derivative itself does not exist. So this curve, the absolute value of x, is not differentiable at 0. So while the f of x is continuous, the derivative is not continuous, and it's not continuous at 0. The derivative is continuous everywhere else. It's just at 0 we have an issue. Take a minute and graph the x cubed. Sorry, cube root of x. That should be the cube root of x. So let's look at the graph of the derivative of the cube root of x. Okay, you know, what's happening at 0 is a little funky. Like, what's the tangent line there? Let's see. So for values of x greater than 1, for values of x greater than 1, the slope of our derivative is going flatter and flatter and flatter and flatter and flatter. So it's approaching 0. So when x is greater than 1, the derivative is approaching 0. So greater than 1, we're approaching 0. Let's label this as the f prime of x. When x is between 0 and 1, when x is between 0 and 1, so here's my graph between 0 and 1, you'll notice that the slope of the tangent is getting bigger and bigger and bigger. It is approaching infinity. Not the most pretty of graphs. And the same thing is true on the when x is negative. When x is getting to a larger negative value, the tangent lines are approaching a slope of 0. And between -1 and 0, the slopes are getting steeper, 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 steeper in the positive direction. So those are approaching positive infinity. This is not a very good graph. So when x is less than -1, the f prime of x is approaching 0. And when x is greater than 1, when x is greater than 1, the derivative is also approaching 0. Okay, and when x is between -1 and 1, we're approaching infinity. So what's happening at 0? At x equals 0, we have an asymptote. At x equals 0, we have an asymptote. The slope is approaching, how about we say f prime of x is approaching infinity. And if you look at our curve, at our root x, cube root x, we're approaching a vertical tangent. So that's what's happening at the origin. You are approaching a vertical tangent. Vertical line has infinite slope. We've learned that vertical line, we say the slope is undefined. It's also considered infinite slope. So we are approaching a vertical tangent. So if you look, right, the tangent is going to be vertical. That's called infinite slope, but it is clearly, the derivative is clearly discontinuous at the origin. So it's continuous everywhere else. And look at my function, great, nice smooth curve, right? Domains all real numbers, ranges all real numbers, no issues. But then when you look at the graph of the slopes of the tangents, there is an asymptote at 0. So one thing to keep in mind is that differentiability implies continuity. Differentiability implies continuity, not necessarily the other way around. You know, you talk about a square as a rectangle, but a rectangle isn't necessarily a square. Same concept. So it's not necessarily true the other way around. Absolute value is a corner. The individual limits exist. but they are a different number, -1 and 1. They don't have to be opposite. They just have to be different values. A vertical tangent, I wrote here, vertical tangent is when both limits approach either infinity or negative infinity. Next part of this video is going to be with your calculator. So go ahead and have that ready. First thing we need to do is familiarize you with some functions on the calculator that you may not be aware of. Absolute value on your calculator is math, arrow over to number, and then absolute value, and it shows up. So whatever, -6. Again, that was math, arrow over to NUM, and then it's number 1. Okay, so we're going to need that when we graph. Other thing that you need to familiarize yourself with is like the cube root. We're going to graph the previous 2 functions. So the cube root will be math and then number 4, cube root. That's going to be important. So let's take a look at the graph. So y equals, let's just start with graphing the absolute value of x. So math, number, absolute value, x. Not sure where you graphed last, but do a zoom 6. And there's your absolute value. So your graph, your calculator will graph the slope of the tangent, f prime of x. So f prime of x has all these different notations. Alpha, window. Number 3 is the derivative. And let's put that in our y equals, sorry. Let's put that in our y equals because we want to graph it. Alpha, window, number 3. And it says d over d, and it's flashing. You should put x there for your variable. I'm going to try and focus this. Oh, that's almost better. There we go. Oh, so much better. There we go. And then I want to find the derivative of the absolute value of x. So remember, that's math, number, absolute value, and then x. So you've just told the calculator to find the derivative of the absolute value of x. So now what your calculator will do is it will find the derivative at a specific point. I want it to graph the whole thing. So I'm going to do x equals x. All right, and let's see what it looks like. Now you'll notice, there it is, -1, and it hops up to +1. If you go to your table, second graph, I was just playing around. Notice that the absolute value is 0, the derivative is 0, and then notice how all the slopes are 1. All the slopes are 1 for positive x, and all the slopes are -1 for negative x. Okay. It's so great. If you look at the bottom too, it tells you, okay, I'm in the column y2 and my y2 equation. There it is. Let's take a look at the cube root. So I'm going to leave these in my calculator. I'm just going to turn them off. Hopefully you know by now that you can do that. Let's look at the cube root. So math, number 4, x. Take a quick look at the graph. There it is. And now I want the calculator to graph the tangents. Y equals the cube, the derivative of the cube root takes a little bit of time on your calculator. Okay, so alpha, window, number 3, which is the derivative. This funky equation comes up. I want to find the derivative with respect to x of the cube root of x. Let's try this again. Math, number 4. Like with the log, you want to find the log of, so I want to find the derivative of x with respect to the cube root of x for all values of x. And it's going to take a minute. And mine is hard to see. Let me change the color. Mine's like in this really weird fluorescent pink, so I didn't do that ahead of time. Let me change the color. Okay, so you can see hopefully better. I changed the color, and it does indeed look like the graph that we did. Looks like actually looks like the graph of 1 over x squared. It's very similar. Okay, so that's graphing derivatives on your calculator. Hopefully some of your confusion was cleared up with this second video.